the equation, I'm actually going to start with the Y-intercepts. The Y-intercepts are simpler for us because all of our equations are written in like the Y equals format. So if we go to find the Y-intercept, we're plugging in 0 for x. Sorry, that's a positive 2. Then you just have to make sure you complete order of operations correct on the right side of the equation where you have something to calculate, and you'll have the y value that you were looking for. So all right, so our y-intercept ends up being 0.46. It's a point on our graph. That's why we write it that way, okay? Is everybody good with that? The y-intercepts, again, are generally not that difficult. Remember, every time I say something like that, I'm not saying that anything should be easy for you. I'm just saying, like, comparatively to what we have to do for the x-intercept, okay, we just have to follow through with the order of operations. For our x-intercept, we just want to put 0 in for y and solve. The reason it becomes more difficult is because the equation's not set up as x equals and everything on the other side. So when you put 0 in for y, you can't just start calculating. You do actually have to solve for x, okay? And if x, which we're looking at a lot of different types of equations where we're writing them in that x minus h format, so x is like inside of whatever function we're studying, then we really want to isolate that function part. So we want to get the squared part alone. He's not here. So if we go to get the squared part alone, so my focus, because all the x's are in one spot. So if there was other x's out here, I couldn't do this. I'd have to multiply it all out and all that stuff. But because they're all inside of this perfect square, I will just want to get that part alone. Okay? So I'm going to add 4 to both sides of the equation. And then the other thing I need to do to get that part alone is to divide by the factor of 2 that's multiplying it. Now that I've got the part alone that contains x inside of it, I want to get rid of whatever the function is. Like if it's a log, I don't want the log there anymore. If it's a radical, I don't want the radical there anymore. In this case, it's a squared. What is the operation that can undo the squaring? Good. So we can square root this specifically so that those inverse operations will kind of cancel each other out. Then we have to do this on the other side as well. And with square rooting, it's a little bit tricky. Remember, you had something squared, and it said something squared equals 2. So let me make it an easier number. If I said something squared equals 4, what number am I thinking of that when you square it, you get 4? 2. Could be. There's also another possibility. Could have been negative 2. So we have to include here plus or minus. I'm not saying when someone randomly walks up to you on the street, like they do all the time, right, and says, what's the square root of 9? You don't say positive and negative 3. The square root of 9 is 3. But if they said, what number did I square to get 9, that's a different question, and it could be 3 or it could be negative 3. So if you had a squared and you got rid of that by square rooting both sides, you need to include plus or minus because of what it could have been. Is this okay with everybody? All right, and so the last thing we have to do to get x alone is add 5. When you guys take your exam on this, our expectation will be no calculator with this. So I wouldn't expect you guys to calculate the square root of 2. I would just expect you to grow comfortable enough to leave it as the square root of 2 and be able to recognize that. So we actually have 2 x-intercepts, 5 plus rad 2, 0, and 5 minus rad 2, 0. You can write them as 2 separate intercepts, or you could write them as 1 point with both the plus or the minus. I understand that means 2 things as long as you understand that that means 2 things. Okay? Any questions on your x-intercept or your y-intercept specifically when we're dealing with a quadratic? All right, so what are going to be the differences when we put up an equation that's a cubic instead of a quadratic? So we're about to do that. What are we going to do that's different than what we did right here? Emily? Yeah. So when we go to solve it, instead of square rooting to get rid of the squared, we're going to have to cube root to get rid of the cube. When we cube root, are we going to have to worry about the plus and minus? No. If I say I cubed a number and I got 8, what number did I cube? It had to be positive 2. It couldn't be negative 2 because negative 2 times another negative 2 times another negative 2 would have made negative 8. So because the odd powers keep their sign a lot better, they're not very mysterious, and there's none of these like weird situations that we have to watch out for right here. Okay? So we're just going to do this with the cubic, and then we'll be done. So this was the cubic function that we graphed yesterday. Okay? And even though it had that 2 in there that made it hard to see the h, and we had to remember about horizontal stretching versus compressing, when you're solving, those things don't matter that much. They're one extra step at the end, that eventually at the end, to get x alone, I'm probably going to have to divide by 2. But other than that, it doesn't change your solving that much. Okay? So let's go ahead and find the x-intercept now that we've been through that solving process. So we put 0 in for y. And the same idea as before. All of the x's are contained in the cube, so you want to isolate that part of the function. So the first thing we would do is add 4. And what would we want to do next? Hear me? Yeah, so multiply or divide by a -1 just to cancel this negative out that's not part of the cube, because we kind of don't want it there. We want to get the cube completely alone before we start cube rooting. Okay, so whether you multiply or divide by -1, and that's where we want to do that cube rooting instead of square rooting this time. And you're going to have to cube root a negative. Is it okay to take the cube root of a negative number? Can you cube something and get a negative number? Then is it okay to take the cube root of a negative number? Yes, it'll just be another negative number, okay? Because again, you can raise a negative to the power of 3 and get a negative. So I'm going to cube root to cancel the operation. So that on this side, I have 2x plus 6. On this side, you could technically leave the negative in there. We don't do that often, but we just know that the cube root of a negative number would be negative. Later, I just have to be comfortable with just writing it as the cube root of 4, okay? And that's okay. And then, again, remember our goal is still to get x alone. So we kind of have to do double the work. First, we have to isolate the cube part. Then we have to re-isolate x all alone again. So now I'm going to subtract 6. So my equation will say that 2x is equal to -6 minus the cube root of 4. And then I need to divide by 2. Be a little bit careful when you do this. I know that 2 goes into 6. So you guys can divide 2 into 6. But remember that 2 is also a denominator for the other term here. So I would either just keep it all how it is. Or if you did divide the 6 by 2, the other way that this could be written is that would now be -3. But the cube root of 4 would still be divided by 2. Okay? And we wouldn't simplify that to be the cube root of 2 because the 4 is in a cube root, but the 2 is not. So those are two different kinds of values. Okay? And so, again, this is an x-intercept, so generally we're going to write them as intercepts. So we would write it like this. Okay? And even though the value looks crazy, that's okay. You could always put it into a calculator if we were using it and needed to plot it on a graph. I'm just going to ask you to find it, so you should be able to leave it in that format for me. Okay? All right, and then go ahead and find the y-intercept. You guys can do that. All right, did I do it right? You guys check mine. -220. Can someone confirm I did it right? I'm decent at math, but arithmetic is not my strong suit, so I mess up my addition and subtraction and stupid things like that. All right, so do we feel comfortable finding intercepts? Okay, so again, our goal for you guys, I'm going to show you homeworks 2 and 3 just so you understand what I'm saying. Again, I'm not checking it till Monday, so you can organize your time how you want. So look at what it's asking you. So you want to graph them. For the graph, you should be able to identify the vertex or that main point, the range and domain, and explain the transformations. Okay? So when I give you a test, I'm not going to ask you that entire chart of characteristics. We did that to review what you should know from Algebra 2. I'm going to focus on domain, range, transformations. Can you have a graph and a table of it? Okay? So for homework, there's 8 quadratics and there's 8 cubic functions. Okay? So again, you could have started yesterday. You could start tonight. Tomorrow you'll have time in class after your quiz. Friday we have a Desmos activity. It took most people like the whole period last time. If you finish early, you'll have time, but otherwise you won't. So if you don't want homework over the weekend and you need to get in your practice with these functions, make sure that you're starting to look at these problems, okay? So I'll leave this up. How much time do we have left? 5 minutes. If anybody wants to do a problem in 5 minutes, I'll just leave this right up here for you.